Okay, so we are going to learn about angle sums. What that means is if I give you angles like this, here's an angle, here's another, here's another, here's another, same thing down here, 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 and here. If I give you an equation, 2x plus 60 degrees, and another one, can you tell me what x equals, the value of just x? And can you tell me the whole degree measurement? How many degrees is this? Does 5x plus 30, how many degrees is that? That's what we're going to be learning today. All right, but before we get into this, we have to do a review of basic angles. Okay, so that is what we're going to learn today. All right, this is our goal right here, to get to this and to solve for x and to find the exact degree measurement. All right, some vocabulary that we are going to go over would be adjacent angles, supplementary angles, complementary angles, parallel lines, transversal, vertical angles, and corresponding angles. Adjacent angles are two angles that are right next to each other. For example, if I have this as an angle and I have another angle right next to it, this angle is adjacent to this one. It's right next to it. Supplementary angles are two angles that when they're adjacent, when they're next to each other, they add up to 180 degrees. For example, if this is 150 degrees, this angle plus this one has to equal 180. So it's the same thing as saying 180 minus 150, which is 30 degrees. All right, and if you want to make an equation out of that, which is pretty much what we're going to be dealing with today, it would be 150 plus x equals 180. To get x by itself, you would do 1 minus 150 minus 150, x equals 30. Complementary angles are two angles that add up to 90 degrees. All right, a right angle is 90 degrees. So say if I have this as 60 degrees from here to here, that angle. This angle, if both of them have to add up to 90, this one should be 30 degrees. So if I wanted to write an equation, 60 plus x, an unknown value, if I did not know that was 30, equals 90, minus 60, x equals 30. Here's another example of that one. Say if this was 70 degrees, how much would this one be? Well, 70 plus 20 gets me to 90, so I can do that. Or I can say 90 minus 70 equals 20. Or I can say 70 plus what equals 90. That what is your unknown. So you do minus 70, x equals 20. So there's lots of different ways to find it. Parallel lines are two lines that go on forever that never intersect. So they're parallel, they never touch. Transversal is a line that cuts through parallel lines. This is my transversal right here. This one right here. Okay. Vertical lines are two angles that are across from one another, that when they're across from one another, they're also called like kissing angles. All right, when they're across from one another, they are the same degree measurement. So if this is 110, the angle directly across is also 110. Okay. Corresponding angles. So let me draw a brief picture. If this, say I'm going to label this as K. If this is K, this is in the top right. So top right, sorry, top left. If this is top left, this is top right. Okay. And this is bottom left, and this is bottom right. This is top left, top right, bottom left, bottom right. If this isn't a top right, up here in this section, where is it down here in the same exact spot? Top left, top left, top left, same position. So that's corresponding angles. Okay, so we're going to go over these again in some vocabulary slides. This was just to explain a little bit about it. Hopefully you remember it from last year. The only thing from last year that should be new would be this corresponding angles. Actually, it's not really new. We just didn't spend that much time on it. But we're going to be looking at this a lot for 8th grade math. So, again, our goal is, if I give you two equations, can you tell me what the x value is and what the degree measurement is? Instead of writing x plus something, can you just give me the whole degree measurement? Like over here, if I give you 140, and that's the whole degree measurement there, can you do that here if I give you equations? So this is the goal, okay? This is what we need to review before we get to this. If I give you one measurement, can you give me all of the other measurements? That's what we are going to review right now to help us get to this goal. All right, let's review this vocabulary again. All right, so parallel lines, a pair of lines that never intersect. All right, so they can look like that. They can look like that. They can look going this way. They can go straight up and down, as long as they never touch. All right, transversal. A line that cuts through a set of parallel lines. So go ahead and draw for me what you remember me explaining on a couple slides ago, well, a couple pages ago. Hopefully you drew something like this, a set of parallel lines and a line going through it. It could be going down from left to right. It can be going up from left to right. It does not matter. All right, but make sure that you are doing arrows at the end of your lines, because these are lines. Lines go on forever. And remember, this one is a transversal. I'll darken it a bit. That one's a transversal. This represents parallel lines. That's parallel lines. Okay, the darker one is a transversal. It's the line that cuts through a set of parallel lines. Adjacent angles. Adjacent angles are angles that are right next to each other. So again, it could look like this. All right. It doesn't matter what the angle, what the degree measurements are. It does not matter. As long as they're right next to each other, meaning that they're touching. If I have an angle here, and then I have another angle over here, but they're not touching, they don't share the same edge or the same vertice. Look, this is the same vertice. They're sharing the same one. Right? Then they're not adjacent. Okay? Adjacent means that they're right next to each other. Okay, like this. They're touching. And where do we see those adjacent angles? In supplementary and complementary angles. All right, supplementary angles are two adjacent angles that add up to 180 degrees. So if I give you a degree measurement, say I give you 150 degrees, and I want you to find the other angle. What would that other angle be? Try thinking in your head. How much would that be? 150 plus what equals 180? Or you can think 180 minus 150. How much does that get? Hopefully you said 30 degrees. Let me give you another one. And none of these angles are going to be drawn to scale. It's just the way that I'm drawing it. And I try to approximate like straight up will be 90. So, you know, halfway from 90 is 45. So that's a little bigger. So I will say if this was 50, how much is this one? How much would that be? What would be the supplement to that angle? What would be the supplement to a 50-degree angle? That represents this one. So hopefully you said 130 degrees. 180 minus 50 is 130. All right, let's look at this one. Complementary angles. Two adjacent angles that add up to 90. So let me draw some examples. If this is 10 degrees here, what would this degree measurement be? So 90 minus 10 is 80, so this is 80 degrees. Okay, this is a right angle, both of these combined. 90 degrees represents a right angle. Okay, a right angle is 90 degrees. And usually this box right here represents that it's 90 degrees. Okay, let me show you another one. If this is 46 degrees, what would the degree measurement of this one be? What would be the complement to a 46-degree angle? That represents this one. So go ahead and figure that out. Okay, that should have been 44 degrees for this measurement right here. If this were x and I said find x, that would be 44. X would equal 44 degrees. Okay. All right. So complementary versus supplementary. How do you remember the difference between the two? Well, one is adds up to exactly 90 and one adds up to exactly 180. Complementary, think about complements because it's cute. Usually, like if you have a sibling who's younger than you, if you're walking down the street, usually somebody will say, "Oh, how cute your baby brother or sister," and they forget about you. Okay? Compliments. All right, compliments because you're cute. They're smaller. People usually associate smaller things as being cute. All right? Supplementary, supply. All right, supply. Think of supply. It means lots of. So that's the bigger one, 180. Complementary, think of something smaller. Right? People usually associate that as cute, 90 degrees. Supplementary, supple, supply. All right? Means lots. So that's the one that has a lot more degrees, 180. This one has 90 degrees. This is 180 degrees. Now vertical angles. They're also known as kissing angles because they look like they're kissing. Angles that are right across from one another. They have the same degree measurement and this is going to help us out a lot. Okay, for example, if I say this is 120 degrees, that means the angle directly across from it is also 120 degrees. And if I know one of these angles, I can find the rest by using vertical angles. And then look, if I cover this one up, if I cover this one up here, what kind of angles is this from here to here? Supplementary. So I know that this angle plus this angle has to add up to 180 degrees. So I can do 180 minus 120, and that will get me 60. And this one's 60 degrees. If this one is 60, through vertical angles, I know that this one is also 60. Do you remember how many angles are in a circle all the way around? If you don't remember, what is it called when somebody on a skateboard flips the skateboard all the way around? 360. All right, so if you are ever worried about if your angles are correct, you can add all of these up and they need to add up to 360. Okay, so let's try another one. If I give you this one and it's 160, go ahead and take a moment and find out the rest of those. Pause this and then come back when you're done. Okay, so if this is 160 degrees, you should know the one directly across from it is 160. If this is 160, I can look at it this way and say, okay, if this is 160 from here to here, what's this one? I could do 180 minus that to get this one, or I can look at it this way. If this is 160, what's this one? It's the same kind of thing. It doesn't matter if I look at it this way or if I look at it this way to figure out the missing angle. So I'm going to say 180 minus 160, which is 20. So one of them is 20. If this one's 20, the one directly across from it also equals 20. So let me get a marker really fast so I can kind of show you with color, just in case. Hold on. Alright, I don't know if this is going to bleed through, but okay, so this angle right here is 20 degrees, and it is vertical to this angle right here, okay, which is also 20 degrees. Okay. Alright, this is a very important vocabulary word that's going to be very useful for everything that we're doing today. So, with all of this information, again, if I give you 1 degree measurement, you should be able to find the rest of them. And this 1 degree measurement could be here, it could be here, or it can be here. It does not matter. So go ahead and pause this and go ahead and try this one out again, well, another one on your own. Go ahead and pause now. Okay, hopefully you said that this was 130 because of vertical angles. Try to use those vocabulary words so that you remember. All right, if this is 130 because of vertical angles, I can say that this one is 50 because of supplementary angles. All right, because 130 plus 50 equals 180. And if this is 50 degrees, the one across from it, because of vertical angles, says that that one is also 50. Vertical angles are congruent. They're the same measurement. Vertical angles, congruent, same measurement. All right, let's keep going. So go ahead and pause this and practice these ones. All right, it may take you about 5-6 minutes maybe. That's okay. Go ahead and pause it and go ahead and do that. All right, so hopefully you said this was 70 degrees. All right, if this is 70 and that's 70, over here or over here, it doesn't matter which way you go. Hopefully you said that this one is 110 degrees. If this is 110, this is 110. Let's look over here. If this is 155, this is 155. 180 minus 155. Okay, make sure you subtract correctly. So 25, verify, 55 plus 25, 50, 60, 70, 80, so 180, perfect. If this is 25, so is that one. And don't forget to be writing the degree measurements. All right, you should be writing those degree measurements. All right, if this is 126, this should be 126 due to vertical angles. All right, you can choose to go this way or this way first. It does not matter. All right, so 180 minus 126. You should get 54 degrees. Okay. So 54 degrees, 54 degrees. Perfect. If at this point you feel confident, if you did all 3 of these correctly, perfect. You're ready to move on. But if not, you should practice these again. And even if you want to make up some of them on your own, that could work too. Okay. To verify if you have it all correct, make sure that if they're across from one another, they're the same degree measurement. Then add them all up and make sure they add up to 360. All right, now we're getting to corresponding angles. We're still in part 1. All right, we haven't reached our goal yet. We're still reviewing. Okay, but this is the last part of the review. So, corresponding angles. Okay, they are angles that are in the same position when a transversal cuts between parallel lines. Here's my transversal right here. Here's my parallel lines. They have the same degree measurement. So if they're the same exact position, they have the same degree measurement. So let's look at this one. Let's pretend this bottom part is not there. And pretend it looks like this. All right, say if I say this is 150 degrees. Let me erase that 0 because it looks kind of small. 150. If this is 150, this is 150. What is this one right here? 30 degrees. If this is 30, this is 30 degrees. Okay, so far, if you can get to this point, you're good. You're at where you're supposed to be. Okay, but now we have this bottom part, and that's where corresponding angles comes in. If I look at this, all right, and I say, okay, oh, it looks like a cross right here. All right, this is the top left, because these are the tops, these are the bottoms. You can think of it that way. That's how I think about it. Top left, top right, bottom left, bottom right. Here's my top left. Which one is my top left right here? In this section. Right here. They are corresponding angles. They are in the same position. So if this is 150, this is 150. And if this is 150, oh wow, look. Oh, I keep writing it like that. Then this is 30, and this is 30. If you look at it, whatever's right here, it's like copying it and writing it down here. But the reason that works is because of corresponding angles. So let me give you another one for practice. If I give you one, can you give me the rest of those? So go ahead and pause this and try that on your own and see what you get. All right, so if this is 140, this is 140 degrees. If this is because of vertical angles, to get to this one, this is a supplementary angle to this one. So I know that 180 minus 140 will get me 40 degrees. And again, these are not drawn to scale. If you can see, this transversal and this set of parallel lines looks exactly like this one. All right, it's not drawn to scale. So if this is 40, this one's 40 due to vertical angles. Now, let's look down here. What would this angle be? This is the top right. What's the top right angle up here? 40 degrees. So this is 40, so this is 40. That means this one must be 140 and this one's 140. It's like copying whatever's up here directly down here. Okay, let's keep going. So with everything so far, if I give you one of these angles, you can give me all of these angles. And there's 1, 2, 3, 4, 5, 6, 7, 8 angles. Okay, so let's just practice that one more time before we move on. Okay, Actually, we don't really need to practice that one more time because the next slide has some practice problems for you anyways. So let me just go over it one more time myself before I let you go ahead and practice the next example, the next couple examples. All right, so if I say this is 20 degrees, and again, these are not drawn to scale. If this is 20, what is this one going to be? 20. Okay. Well, what is this one going to be? 160. Okay. What is this one going to be? It's in the same position as this one, so it should be 160. So that means this is 160, this is 20 degrees, this is 20 degrees, and this one is 160. Okay, the reason why it's the vocabulary word that we're using for why this is 160 and this is 160 is due to corresponding angles. That's what they are. They have the same degree measurement and they're in the same exact position. Alright, so I'm going to give you about 5 minutes, or you take as much time as you need. Go ahead and pause this so that you can do these 3 examples, because this is really going to help you before we actually do the second part of our lesson today, alright, which is the goal part. So go ahead, pause it now. Alright, welcome back. Let's see. This is 30, so this should be 30 degrees. If this is 30 degrees, this one should be 150 degrees. These are very easy numbers to work with. So this is the bottom left. Bottom left over here is the same position as this 30 degree mark. So 30, 30, 150 degrees, 150 degrees. Let's look at this one. 140. This should be 140 because of vertical angles. Alright, I like to go around wherever that angle is first, and then I think about the bottom part. Alright, so here's 140, so that means this is 40, because I know 140 plus 40 equals 180. This should be 40 degrees here. Okay, and remember, I just copy the same thing down here because of vertical angles. Sorry, because of corresponding angles. So right here, this is 127. If I want, I can skip down here. I know these are in the same position. These are in the same position. Then I have to do 180 minus 127 to figure this part out. So 53, 50, 60, 70, 80, 100. I'm just back checking, making sure that they add up to 180 in my head. So then this is 53 degrees, 53 degrees, 53 degrees, 53 degrees. Okay, so hopefully you got those right. If not, don't worry. 3 more examples for practice. All right, for review, and before we do the other part. So go ahead and pause this. All right, welcome back. Let's see how you did. So if this is 85 degrees due to vertical angles, this one should also be 85 degrees. Let me zoom in a little more. Okay, so if this is 85, this should be 85. If this is 85, that also means this is 85 degrees and this is 85 degrees. All right, so 180 minus 85 is 95, so that means this is 95, this is 95 degrees, this is 95, and this is 95 degrees. Okay, hopefully you can see that clearly. Alright, so over here, if this is 70, this is 70 degrees, so this is 110 degrees, 110 degrees, all the way down here, 110, 110, 70 degrees, 70 degrees. Right, when I make this little arc, All I'm saying when I'm doing that is that the measurement from here to here, that's just the showing that it's a degree. It's okay. It doesn't really mean that much, all right? All right, here, if this is 135, this is 135 degrees, all right? Down here, this should be 135 degrees, and this should be 135 degrees. So if I do 180 minus 135, I should get 45 degrees. So that means the other one is 45 degrees, 45 degrees, 45 degrees, 45 degrees. All right, remember, corresponding angles is the one that allows me to say whatever's up here is down here if they're in the same position. And that's going to help me a lot for the next part of this lesson. So if you can do all of this, you are ready for the next part of the lesson. All right, if you cannot, please keep practicing these. All right, now we're at the goal part for angle sums. Okay. All right, just checking to make sure because it looked a little blurry. All right. So we just did these examples, all right, but let me show you what it will look like with this, with the second transversal. All right, so we've done it where we have parallel lines and one transversal, but what if we have two transversals? It doesn't really make a difference. Look, if this is 120, I know this is 120. I'm going to pretend this transversal is not there, so I'm going to cover it up. Okay, if this is 120, that means this is 60 degrees, and this is 60 degrees. Same thing that's up here is going to be the same thing on bottom. Because of corresponding angles. Now, whatever's up here is the same thing down here. Well, what if I turn it and say it this way? Well, it's the same kind of thing. Whatever's up here is down here. If this is 60, this is 60 degrees. You can think of it as top left, or if you thought of it this way, this is top right, 60 degrees. Okay, so I'm just going to flip it this way. This is 60, so this is 120 degrees, 120 degrees. I can look at from here to here, or from here to here. It's going to be the same thing. Okay, so if this is 60, this is 60 degrees, this is 60 degrees. If this top right is 120 degrees, it corresponds to this one. This 120 corresponds to this one. Okay. So let's do one more example of that, and let's have you do one just for practice. Okay. Oh, that's not, I should have slanted some of these lines a little more. So remember, it's not drawn to scale. Okay. So say if this is 130 degrees. If I give you one, go ahead and practice giving me all of them. Go ahead and pause this now and go ahead and do that. Alright, so hopefully you're back. This is 130, so this one's 130. Let me just fill in my 130s first, okay? If this is 130, and I think of it this way, this is top left, then top left is right here. So these two are also 130 degrees. That's supposed to be my degree measurement. Let me rewrite that for us. I'm writing in pen so that it could be darker for you, so I have to use whiteout if I need to erase. Alright, now looking down here, if I turn it, this is top right, so top right here is 130 degrees. This is 130 degrees as well, so 30. So if I look over here, top left, top left. Ooh, I keep doing it when the last digit is a 0. I keep thinking that's the degree measurement symbol. Okay, so I have all my 130s in. So if this is 130, what would this one be? 50. So all of these blank ones are 50. Just make sure they're all in the same position. Okay, and no matter how you turn it, however it looks here, it should look exactly down there. If you turn it this way, however it looks up here should look the same down here, and so on, no matter which way you do it. Okay, let's keep going. Now we're at this part. Okay. Alright, angle sums example 1. So I'm going to start with pencil because I'm going to be doing lots of markings as I'm teaching you how to do this, and I don't want to use whiteout with the pen. Okay, so let me zoom in a little closer. Now, this is our goal, for us to be able to find the degree measurement of x, and eventually the whole degree measurement, right, or all of the angles if I'm given equations like this. Okay, but before we do that, there's things that you need to be able to recognize. You need to recognize if these equations should equal each other, or if they should add together to equal 180 based off where they land. Okay, for example, if I look at this angle and I pretend that is not there, and I pretend this is not there, I'm going to just pretend they're not there. If I'm saying that this is angle star, where else is angle star? Well, this is angle star, this has to be angle star. And if this is angle star, this is bottom right, this one has to be angle star, and this one has to be angle star. That means these have to be the same degree measurement because they are the same, they're the same star, they land in the same spot. So if they land in the same spot, they must equal each other. But how do they equal each other if one, let me erase this, how do they equal each other if one degree measurement is 2x plus 90 degrees and the other is x plus 95 degrees? What? If they equal each other, how does that make sense? Well, you set them equal to each other. If they equal each other, set them equal to each other and solve for x. Okay, well, when we're solving, you know that I like to move my variables to the left and my constants to the right, but remember, there's lots of different ways of solving multi-step equations. You get to choose. So I'm going to move this over, I'm going to do the inverse of positive x, so minus x, that cancels. Whatever you do to one side, you have to do to the other. 2x minus x is just x, plus 90 equals 95. Then I minus 90 minus 90, x equals 5. So x equals 5. I just solved what x equals. But x does not represent the degree measurement. X just represents this part, x and x. And if you think about it, x is 5, so what's 5 plus 95? This whole degree measurement is 100 degrees. Okay, but we're going to see that a little later. Right now we're just focused on trying to find x. Okay. So again, what made me set these equal to each other? Go ahead and think about that. Pause this really fast and think about why did I set them equal to each other? Go ahead and pause and then come back once you have an answer. Okay, hopefully you said that we set them equal to each other because they're corresponding angles. They're in the same position. They're congruent. Right? If this was angle star, so is that. And if angle star is in the top left here, it's vertical to this one, meaning they're the same degree measurements. So if they're the same degree measurements, I can set them equal to each other because they are equal to each other. Alright, next example. Alright, so for this example, I'm going to, let's just use the stars again, and let's see where these stars land. So here's a star. I'm going to put a star here because it represents for this one. Okay, top left, here's a star, top left, top, ooh, look, it lands in the same position again. So I'm going to set these equal to each other. 2x plus 40 equals 3x plus 25. Okay, so I like to move my variables to the left. I get negative x plus 40 equals 25, minus 40, negative x equals, so I can show my work on the side, negative 15, take the sign of the further number away from 0, alright, and here's a negative, so here's a negative. Whatever I do to one side, I have to do to the other. So I'm just going to divide by negative 1, because a negative divided by negative is a positive, so I get positive x equals 15. So x equals 15. There we go. We just found the value of x though. We did not find the degree measurement. To do that, you would plug 15 in here. So 2 times 15 is 30 plus 40. That gets me 70 degrees for that measurement right there. And again, these are not drawn to scale. But we're going to be finding those degrees measurements in a couple more examples. Alright, let's keep going. Alright, let's look at this example. We need to find the value of x. So let me do my little stars. Here's a star. You don't have to use stars. You can use x's, you can use check marks, you can use smiley faces. It does not matter. Okay, so here's a star, here's a star. Top left corresponds to this top left, corresponds to this left. Oh, sorry, corresponds to this one. Sorry. This, okay, so this star corresponds to this one, which is a vertical angle to this one, so they're the same. So if this is a star and this is a star, this is not a star. But I know if I do the star plus this, if I do this angle plus this angle, the star plus this equation, they should add up to what? 180 degrees. So if I say this equation, 7x minus 37 plus the star is this equation, that should equal 180 degrees. So this is the second thing that can happen. The first thing that can happen is when they land in the same position, right? Meaning that they're congruent, right? With corresponding or vertical angles, that they are the same degree measurement, I can set them equal to each other. But if they're not the same degree measurement and they're adjacent, they're right next to each other, then I add them up and set it equal to 180. So let's go ahead and do that. Let me sharpen my pencil. Hold on. Alright, so for this type of multi-step equation, I need to simplify before I start moving things from one side of the equal sign to the other. So I can see that I can combine these x's. Alright, 7x and positive 4x. That's 11x. And negative 37 plus 30, that makes negative 7. Different sign, subtract. 37 minus 30 is 7. Take the sign of the number that's further away from 0. Negative 37 is further away from 0 than positive 30, so negative. So negative 7 equals 180. Then I'm going to add 7. Add 7. 11x equals 187. Alright. Now I'm going to divide by 11. Divide by 11. X equals, I don't really know that. So you could do long division to figure it out. But I know the answer is going to be 17. Okay, if you just do the work, 11 goes into 77 7 times, then that gets me 77, 0, nothing left to bring down that I have to, so 17. So x equals 17. Again, x is not the whole degree measurement, it's just the value of this one, okay, of just the x. And here too, just the x, not the degree measurement. Alright. Let's look at this one. Let me adjust this because it's looking, need to refocus. Okay. So I'm not sure if it was blurry before too, so hopefully you were able to see this. Okay, so equals 17. Alright, I did long division to equal 17, and I was saying that it just represents the value of x and not the actual degree measurement, just the value of x. Okay. Alright, let's continue. So far you've seen two examples. One example where they're in the same position. So let me go flip back again. So one example where they're the same degrees that, you know, according to vertical and corresponding angles, they're the same degree measurement, so I could set them equal to each other. And we just saw an example of when they're not in the same position, they're not congruent, they're adjacent, they're right next to each other, so you would have to add them up and set them equal to 180 because they're supplementary angles. This angle plus that angle equals 180. So 7x minus 37 plus the star, which we are representing as 4x plus 30, so 4x plus 30 equals 180. Okay, now let's find actual degree measurements. It says, what is the degree measurement of k? Okay, so before we find k, I want you to find x. Alright, don't find k yet. Find just x. Alright, I'm going to have you pause this after I'm done talking and just find the value of x. And don't go on, just in case you make a mistake. Don't go on. Come back to the video and then I'll go over how to find x and then I'll give you time to practice finding k. Okay, so go ahead and pause this video and find the value of x. Alright, so I asked for you to just find the value of x so far before we actually find the degree measurement of this angle. Okay, right here. So I'm going to use stars. So here's this star represents this equation. It's vertical to this one, so they're congruent. Top left, over here, top left, star, star. They land in the same spots. So they're corresponding to each other. So that means that they're congruent. They should equal the same. So I'm going to, down here, I'm going to write 6x minus 35 equals 4x plus 11. If you accidentally added them together and set them equal to 180, go ahead and erase that and pause this and use this information. Hopefully you realize why you made a mistake. Pause it and try it again using this, and then come back. If not, just keep watching. Alright, so I'm going to minus 4x on both sides. Okay, so I get 2x minus 35 equals 11, plus 35 plus 35. 2x equals 46, divided by 2, divided by 2, x equals 23. So x should equal 23. Not degrees. Remember, this x does not represent a degree. It just represents the value of x. So before we move on, I'm just going to verify myself. I'm going to check my work. Okay, alright, so x equals 23. I have not actually answered the question yet. Alright, we're just trying to do a step by step. Now, I need to find k. Well, if I know that x equals 23, if I plug in 23 for x here and find this degree measurement, because once I plug it in, I'm going to have the degree measurement. If I do that, then I can use, I can find the supplement to this angle, which is k, right here. So let's go ahead and do that. So this is part 1. I can say this is part 2, just to organize my work. So I'm going to say 6 times 23 minus 35. Okay. Alright, 6 times 23. 23 times 6, 18, 12, 13, 138 minus 35. Okay, that is going to leave me with 103. So let's just verify. Yep. Alright, so that means this is 103 degrees right here. If this is 103 degrees, what is this one? They're supplementary angles. So I can say 180 minus 103 degrees, and that will get me 177 degrees. So k equals 177 degrees. And if I know one, I can find all of them. But right now I don't have to, because the question just asked me what is the degree measurement of k, and we just solved that. 177 degrees. Alright, so go ahead and pause this and just review your steps of what you did to get to this answer. Okay. Our last example. Here's our last example. You go ahead and figure it out. Try to find the measurement of P. Alright, go ahead and figure it out. Break it into 2 parts. Find the value of X first, and then plug it in to find P. Okay, so go ahead. Alright, so I'm going to use my little star trick. Well, let me do smiley faces this time. Smiley face, smiley face. Okay, top left, smiley face, smiley face. Alright, turn it, bottom left is smiley face. And this one's smiley face. So that means this one's not a smiley face. So they're not equal to each other. So I need to add this up to the smiley face. So I'm going to write x plus 11 plus smiley face. Smiley face was 3x plus 1. I'm going to add them up to equal 180, because when I add them up, they both should equal 180 together. Well, they should equal 180 together. Alright, combine like terms. 4x plus 12 equals 180. Minus 12 minus 12. Okay. So then that cancels. Remember, whatever you do to one side, you have to do to the other. So I get 4x equals 168 divided by 4 divided by 4. X equals 42. And I could think 4 goes into 16 4 times, and 4 goes into 8 2 times, so 42. Alright, so that helps out. So I just found out the value of x, and x. I did not find the value of p yet. So to do that, well, look, this one is vertical to that one. So they must be the same degree measurement. So if I plug in 42 for this one, alright, it should get me, let's see, x plus 11, so 42, because x is 42. 42 plus 11, that is going to be 53. 53. Okay, so if this is 53 degrees, that means P is 53 degrees. So P equals 53 degrees. Okay. And remember, these do not equal each other. If they equaled each other, I would set them equal to each other. And if I were to plug the value in to either one of them, if they were in the same position, not like this one, then when I plug them in, if I were to plug them into both of them, they would equal the same answer. They would both equal 53, but they're different angles. For example, if I do 3 times 42 plus 1, 42 times 3, alright, 42 times 3 is 6, that's 12, 126 plus 1, that's 127. Well, look, 127 plus 53, that equals my 180. It makes sense. Okay, so please make sure that you go over these examples. Try rewriting these problems again on another sheet of paper for practice before you start your homework, right? And then come back here to check your work and review your notes, watch the video again just to check the answers. So remember, there is a difference between the two that I displayed to you. When you set the equations equal to one another, and when you add the equations together to set it equal to 180. Alright? When you set them equal to each other, it's when they are congruent. Okay, like 5x plus 2 equals 6x minus 5. I just made that up. When you add equations together and set it equal to 180, right, that's when the angles are not congruent. Right, they don't correspond, they're not in the same position. Right, so you would do like 5x plus 2 plus 6x minus 5 equals 180. Okay, so it's just when the angles are adjacent, like this last one. Oh, sorry, these ones are cross. Oh yeah, these are adjacent, they're right next to each other. This one was right next to my smiley face angle, which is the 3x plus 1. They were adjacent. They were not in the same position. Alright, that is the end of the video. Alright, so hopefully you understand this. If not, rewatch the video. Do the problems again on your own. That will help out a lot. And this is a huge part of, it's a good summation of 8th grade math because you have angles in here, you have multi-step equations in here. Alright, so this is a pretty good standard to be learning. Alright, thank you to the interpreter. I appreciate it. See you guys later.